So now start the new topic, that is three-phase system. Three-phase system. Let's see what is the three-phase system. Okay. So in our three-phase system, the syllabus is our syllabus content is the first topic of three-phase system is advantage of three-phase system over single-phase system. Okay, the first topic is. Then the second part of this topic is basic definition of three-phase system. Then in the next part we will see types of three-phase connection. Okay, and in that we have mainly two type of connection, that is a star and then delta connection. But if you pair these two, then we have star delta and delta star connection also. Okay, so the first topic is advantage of three-phase system over single-phase system, basic definition of three-phase system, then types of connection, and the last one topic is three-phase power measurement. Okay, so we will also see this thing, three-phase power measurement. Okay, so we will start from three-phase system advantage. Okay, now let's start the three-phase system advantage. So advantage of three-phase system over single phase now. So I'm just taking one thing. Now I'm taking this single line diagram of a three-phase of a power system. So it is your generating station, and the middle one is called transmission system, transmission system, and this one is your distribution system. Okay, now at the generating side we are generating three-phase voltage. Generation is done at three-phase voltages, and example of three-phase voltage are there's 11 kV and 30 kV. Now, and in India that is 25 kV generation, but in the world it is 30 kV. Okay, so that means in our power system we are generating three-phase voltage, and we are also generating three-phase power. Okay, now your transmission system is of two types: primary transmission system and secondary transmission. Okay, so your transmission system is also in three-phase system. Okay, similarly you are having three-phase distribution system: primary distribution, and secondary distribution. Okay, now this is also done, but in secondary distribution system it is three-phase, but in secondary we have three-phase or single phase. The example of it is 400 volt and it is 220 volt single phase. That is home consumer. Okay, so let's start now. From the single diagram of a power system, it is clear that we are generating three-phase power, we are transmitting three-phase power, and we are also distributing three-phase power, except the secondary distribution system. Okay, so why we are transmitting, generating and distributing the power or voltage in three phase? That is the main question. So we have a number of advantage of three phase system over single phase system. That's why worldwide every country is generating three phase, transmitting three phase, as well as distribute three phase power, except the single phase consumer load. Okay, so what are the advantage we will see, because theoretical question can ask from these advantages. Okay, so let's start the advantage of three phase system over single phase system. Okay, so I'm just taking first advantage number first here. I think I just erased it so that you are more comfortable. Yeah. So first advantage first of three-phase system. Now first advantage is in three-phase system, total instantaneous power in three-phase system is constant. Okay, what does meaning? Let's see. So it is PT is 3 Vp Ip cos phi. Okay, this is a three-phase power that is constant. Okay, but when you study your single phase system, I'm just giving you an example of all single phase system now. PT is equals to Vrms Irms minus Vrms Irms cos 2 omega t. If you remember for the resistive load, so it is one for resistive load. If you remember, then PT is equals to minus plus Vrms Irms sin 2 omega t. Okay, and for purely inductive and capacitive load. ठीक है यहाँ तक. Now if you see the RL series or RC series circuit, then PT is, if you remember, it is Vrms Irms cos phi plus minus, okay, plus it is pure plus Vrms Irms cos 2 omega t plus minus phi. It is for RL and RC circuit. If you remember, okay, circuit. So first you compare in three-phase system, the total instantaneous power is constant. That means it is not depending upon the time, and there is no double frequency component. But in your single phase system, this is in single phase system, for resistive load, for purely resistive load, purely inductive load, purely capacitive load, and for RL and RC load, the instantaneous power is time dependent, and this instantaneous power has drawback. What is drawback? First drawback of this instantaneous power is it produces more noise, more vibration. It produces more vibration, noise. Okay, so to eliminate this, to reduce it, we require extra devices, that is called auxiliary devices. So cost is high. High. Okay, so this is our first point. In three-phase system, the total instantaneous power in a three-phase system is constant. That constant power is this. While in case of single-phase system, the total instantaneous power is pulsating. What is this? It is pulsating. So all these power are pulsating power. Okay, pulsating power. Agree? So this is the advantage of three-phase system over single-phase system. In that we have studied that three-phase instantaneous power is constant, while the single-phase instantaneous power is pulsating, and due to the pulsating nature of power, it is having more noise, vibration. So to reduce it, we require extra or auxiliary devices. So the cost of the system is high. So this is the reason number one. That's why we are using your three-phase power. Okay. Now second advantage. Let's see what is that. Now, what is the advantage number second? Now, in three-phase system, the weight, and in single-phase system, weight is 3/4. The ratio of weight in three-phase to single-phase is 3/4, and 3/4 means what? 0.75, and 0.75 means 75%. What is the meaning of that? For same rating, for same amount of power, voltage and loss, for same amount of power, voltage and loss, three-phase system is more economical than single-phase system. So it is the advantage number second. Okay. Third advantage is what? Now, what is the third advantage? From the three-phase system, we can drive single phase, two phase, 6 phase, 12 phase, 48 phases. So from the three phase we can drive, or we can have the single phase, two phase, 6 phase, 12 phase and 48 supply. But if you are having single phase and you want to drive the 3 phase, 12 phase, you cannot. Okay, and your 48 phase supply is used in aluminum industry to melt the metals. Okay, so these are the first three advantage. The first advantage is what? In three-phase system, the total instantaneous power is constant, while in case of single-phase system, the instantaneous power is pulsating, and due to the pulsating nature of power, it is more noisy, more vibrating, so it requires extra devices, so cost is high. Now, second advantage is what? In three-phase system, the weight is 3/4 of the single phase, so it means it uses 25% less copper or the material. Okay, So it is more economical because material cost is the cost is derived from the material. Okay, then the third advantage is what? Three-phase system is from the three-phase system we can drive single phase, two phase, six phase, and 12 phase up to 48 phase, and that are used by different industry. Now let's see the next advantage of three-phase system. Okay, so we are having three advantages here. Now let's see the fourth advantage. Now if you see the fourth advantage, now the fourth advantage, since in three-phase system we require 25% less material, so the losses are less because the losses occurred in material. So losses is what? Losses is of two type: copper losses, PCU, and P iron. So material is less now, so less losses. So since it require less amount of material, so losses in three-phase system is less. Okay, this is the fourth point. Now fifth point, in three-phase system, since efficiency is what? Output upon input, that is equals to output upon output plus losses. Okay, now in three-phase system we require less amount of material, so losses are less. If losses are less, then efficiency of three-phase system is better than the single-phase system. So in the next advantage, the efficiency of three-phase system is greater than the efficiency of single-phase system. Third advantage. Now since the copper losses are less and losses are also less, so if you know the voltage regulation is what? IR drop plus minus IX drop. Okay, so the voltage regulation of three-phase system is better than single-phase system. Okay, just because of material we have more efficiency, better voltage regulation, and low losses. So these are the 6 advantage. Now the 7th advantage of three-phase system is what? All three-phase system are self-starting. All three-phase system are self-starting except synchronous machine. Okay, why it is? Since when a three-phase supply, when a balanced three-phase supply is given to a three-phase winding, a rotating magnetic field is developed. Okay, when a rotating magnetic field is developed, and when you have such type of magnetic field, your machine is self-starting. But your single phase machine are non self-starting. All the single phase machine are non self-starting, like single phase induction motor. Then you require the phase split method, capacitor start, capacitor run. Different methods are available for that. So your three-phase system are self-starting except synchronous machine, because in three-phase system we are having the rotating magnetic field, but in case of single-phase system we don't have rotating magnetic field. Again we are having pulsating magnetic field, and that pulsating magnetic field is resolved into two parts. One is moving in forward direction and other is moving in backward direction with same speed. So the resultant magnetic field is zero, or the force is zero. So this is the 7th point. Now next point, if you see, three-phase system are more stable. Three-phase system are more stable than single phase system. Okay, and if we see the next advantage, since the amount of material required in three-phase system is less, low losses, high efficiency, better voltage regulation, and if you see, if they take less amount of material, then size of three-phase system is compact as compared to single phase system. So these are the some advantage of three phase system over single phase system that we have to study. And one more advantage, if you want to see, the power factor of three phase system is better than single phase system, and the parallel operation of machine is very easy in case of three phase system as compared to the single phase system. You want to write, you can write the power factor. If you want to write, then power factor of three phase system is better than the power factor of single phase system. And last advantage is what? Parallel operation is easy. Parallel operation of three phase system is easy. Okay, so we have 11 advantage, and the major three advantages are first, second and third. Due to these reason we are using three phase system worldwide for generating, transmitting and distributing power from sending end to receiving end. होपफुली ये बात समझ में आ गई होगी, एडवांटेज आपको क्लियर हो गए होंगे। और अगर आप इसी को और डिटेल में पढ़ना चाहेंगे, देन यू हैव थ्री फेज 4 वायर सिस्टम, थ्री फेज 3 वायर और थ्री फेज 4 वायर सिस्टम भी requires less amount of copper in comparison to all other system. If you compare with single phase, two phase, three phase, other phase, the three phase 3 wire system require least amount of copper, and copper means material, then it is more economical as compared to other. So these are the advantage. Now we will start the next topic, the basic definition related to थ्री फेज सिस्टम. सो स्टार्ट करते हैं अपने नेक्स्ट टॉपिक्स के जो आगे है, बेसिक डेफिनेशन रिलेटेड टू थ्री फेज सिस्टम. स्टार्ट करते हैं अपनी बेसिक डेफिनेशन विद रिस्पेक्ट टू थ्री फेज सिस्टम. सो डेफिनेशन रिलेटेड टू थ्री फेज सिस्टम, देखते हैं क्या है ये. सो फर्स्ट डेफिनेशन है हमारी, बैलेंस्ड एंड अनबैलेंस्ड सप्लाई. ओके, सो वी विल सी द फर्स्ट बैलेंस्ड एंड अनबैलेंस्ड सप्लाई. ओके, नो अगर हम सिंगल फेज की बात करें तो VT इक्वल्स टू हमारी इक्वेशन थी VM साइन ओमेगा टी. ठीक है, ये तो होगी सिंगल फेज सप्लाई की बात. ठीक है, VT इक्वल्स टू VM साइन ओमेगा टी, इट इज VA, एंड VB इक्वल्स टू साइन ओमेगा टी प्लस माइनस 90 डिग्री. दिस इज फॉर द टू फेज सिस्टम. ओके, इज ऑल्सो VM साइन ओमेगा टी. ठीक है यहां तक ना. अगर हम थ्री फेज सिस्टम की बात करें तो VA equals to VM sin omega t, VB is equals to VM sin omega t minus 120 degree, and VC is equals to VM sin omega t plus 120 degree. ठीक है यहाँ तक. So these are with respect to three phase system. Now if we have phasor notation, then V is equals to V angle 0 degree. Okay, and for three phase system, VA is equals to V angle 0 degree and VB is equals to V angle plus minus 90 degree. Okay. Now for the three-phase system, VA is equals to V angle 0 degree, BB equals to V angle minus 120 degree, and VC is equals to V angle plus 120 degree. So these are the notation for the different system. Okay. Now what is the definition of balanced supply? Now a supply is said to be balanced. A supply is said to be balanced if their phases have equal magnitude and they are having 0 and 90 degree in two-phase system and they are displaced 120 degree in three-phase system. Let's apply this definition. So for the two-phase system, magnitude and angle is what? 90. For three-phase system, the magnitude and angle is what? Let's see, angle here, or magnitude is also here. Okay. So अगर हम बात करें एक supply is said to be balanced supply in three-phase system की अगर बात करें, a supply is said to be balanced if the phase voltages are having same magnitude and they are having 120 degree phase displacement with respect to each other, then they are said to be three-phase balanced supply. But for the two-phase system, a two-phase supply is said to be balanced when their magnitude are equal, when their phase voltage magnitude are equal, but they are apart or displaced from one another by 90 degree. So these are the definition of balanced supply. If any one of the condition is violated or not fulfilled, then your supply becomes unbalanced. Okay. So let's write the definition of balanced supply. अगर हम two phase के लिए लिखना चाहें, a two phase system is said to be balanced if both phases are having same magnitude and they are displaced from one another by 90 डिग्री. ठीक है यहाँ तक? तो इसको अप्लाई भी करके देख लेते हैं क्या है ये डेफिनेशन. सो अगर हम प्लस 90 लेते हैं, देन अगर इसका फेजर डायग्राम बनाए तो देखिए क्या होगा. इट इज योर VA, that is at V angle 0 degree, and you are taking the second phase at 90 degree plus 90 degree, then it is phasor diagram of this. It is VP, that is equals to V angle plus 90 degree. So this is the balanced condition for a two-phase system. Okay. Now let's define the balanced supply condition for three-phase system. A three-phase system is said to be balanced when all phases are having same magnitude and displaced from one another by 120 degree. Okay. So let's mark the condition of balanced supply. Magnitude same and 90 degree in case of two-phase system. For three-phase system, same magnitude and angle is how much? Angle is this. So अभी क्लियर हो गया होगा कि बैलेंस सप्लाई और अनबैलेंस सप्लाई का क्या क्या मीनिंग होता है। अगर इनमें से कोई एक भी कंडीशन है अगर ब्रेक होती है, then your supply is not balanced. Suppose your magnitude is not same or angle are same, then it is unbalanced. If your magnitude are same and angle are different, then it is unbalanced. So these are some example of balanced and unbalanced supply. Okay, now we will draw the phasor of for this system also. So this is your VA, but which is at angle 0 degree, which is at angle 0 degree. Now the next voltage is minus 90 degree, minus 120 degree. So minus 120 degree is here. So it is VV, that is equals to V angle minus 120 degree, because negative angle are in clockwise direction. Similarly, you are having C voltage, then it is in this direction because positive angle are drawn in anti-clockwise direction. Okay, so if you see, all the phase voltages are having 120 angle. All the phases are having 120 degree, 120 degree. Okay, now these are balanced phase. Now their magnitude are also same. Their magnitude are also same. So this is the phasor diagram of a balanced supply. Okay. Now one more condition is exists for a three-phase balance system. So for a balance system, if I will write here, if a three-phase system is balanced, I will write here, if a three-phase system is balanced, then the phasor sum of voltages, is equals to 0. How it is 0? Let's see. I think it is over, and you all have understood the basic concept of the balance supply. Now let's erase this thing, then we will also find the balance supply condition also. Okay, now for a system to be balanced, in case of three-phase system, then VA phasor, BB phasor and VC phasor should be equals to 0. Let's see how it is possible. Okay, now V is what? V angle 0 degree, and it is at V angle minus 120 degree, and it is at V angle plus 120 degree. Is that equals to 0? So right hand side is 0. Now prove the left hand side is also 0. So it is just we take common, cos 0 plus j sin 0, then it is what? Cos 120, because cos is an even function, then it is minus j sin 120 degree. For that cos 120 plus j sin 120 degree. Okay, I hope so you are समझ में आ रही होगी. Now these are cancel out, and this is 0, so it is 1. Okay, now if you see, the cos 120 and cos 120 is minus 1 by 2 and minus 1 by 2, so it is V minus 1 equals to 0. So in case of three-phase system, a supply is said to be balanced when the phasor sum of all the phase voltages are 0. So let's write a three-phase system or supply